Good evening, everyone. I hope everyone is doing well. My name is Tepankati, and I will be taking you guys through today's session, the mathematics session, which is finance. I know you've already had an amazing session with Mr. Rangaka on chemistry earlier today. Now it's time to shift those gears and level up your math game, right? So tonight's session is especially or specially paced and focused for you, our incredible rising stars. Keep on showing up and doing the work. You're definitely on your way to greatness. Whether you're joining us on Zoom or TikTok, you're definitely in the right space to ask your questions, right? Take your time and get the support that you need. Before we dive in, remember to like the session, subscribe or follow the learning space, and share it with your classmates because success is better when we all win. Right. Now let's dive right into it. I'm going to share my screen and then we can get working on finance. Please remember you need pen and paper and your calculator. Okay. You guys should be able to see my screen in a second. It is loading. If you can see my screen, please put a thumbs up. There we go. So you guys can see my screen. I'm happy about that. Now, without wasting any time, let's dive right into it. Okay. So like I said, today we will be looking at financial mathematics. All right. Now, we're going to start from the very basics, simple interest, and then we're going to move on to compound interest. Okay. Now, let's talk about simple interest, right? These formulas are given on the formula sheet. So simple interest is the most easiest one. I usually say simple interest is the simple one to do, right? Now, we know that we have AP and I and N, right? Now, A stands for the accumulated amount, right? What I say that this is the end amount, right? And then P is the principal amount. This is the beginning amount. Okay. Then we also have the interest rate as a percentage. Okay, let me just remove the one because it's just a percent. We don't know how much yet, but we know it's a percentage. And N would stand for number of terms, right? So some people would say number of years. I prefer saying number of terms because let's say maybe we have an investment that is going on for only 8 months or only 6 months, right? That can be confusing if we say 0.5 years. That's why I just say terms because it could be weekly, it could be monthly, it could be daily, right? Those are what all those letters stand for, right? Now, when we are talking about growth, we need to refer to the positive one. Notice that the formulas are the same except the signs. So this one would represent growth, simple interest growth. And then this would show you decay when it's getting smaller. For example, what could be an example of decay? Let's say your phone, the smartphone that you use, you bought it at the beginning of last year. Because you have been using it, if you tried to sell it today, you cannot sell it at the same amount that you bought it for because it has depreciated in value. Okay, that's when you can use decay. And that's, in a nutshell, simple interest and simple decay. Right. Now moving on. Compound interest and decay. Now, I want to go back to simple interest. Let's compare these formulas. The simple interest formula looks very simple And the compound one, let me just write the simple one here. A is equal to B into 1 plus I multiplied by A. This looks simple. The compound one looks a little bit complicated because there is a power now. There's an exponent there. Now, because it looks rather complicated, it must be compound. And that's how you can differentiate between the two. Because I always used to make a mistake. I used the simple interest where I had to use the compound interest. Now you know which one to use. Okay. Now AP, I, and N still mean exactly the same thing, except now you're dealing with compound interest where the periods are not the same. With simple interest, you were dealing with it on an annual basis. On compound interest, it could be daily, it could be monthly, could be weekly. I'm not going to mention all of them, but they will tell you the compounding period. Okay? Now, this formula here is also referred to as the reducing balance. Balance. That is the one with decay, reducing balance formula. Now, going back to the simple interest one, this is also known as linear depreciation. Because it follows a straight line. How does it follow a straight line? A is equal to In plus P if you multiply the P in. So this is the same as Y is equal to MX plus C. That is why it's linear depreciation. Hope that makes sense to everyone. Now, reducing balance has the power. Okay, now moving on. I'm going to start with a lot of explaining before we jump to the questions. So please make sure you understand my question, you understand my explaining, right? If you want me to repeat something, you need to be very specific with which part you want me to repeat. Please don't just say repeat. You need to say, so please repeat question number so and so. Okay. Now, looking at nominal interest rate, nominal and effective interest rates. Right. Now, which one is which here? They can be quite confusing, I know, but the nominal interest rate is the one that is stated when you see an advert and they're saying you can earn 6%. That is the nominal interest. Or when they're saying maybe you wanted a loan from a bank because you want to start a business, I'll say the interest rate is going to be prime plus 2%. That is the nominal, right? This is the one that they advertise. But it does not consider how many times in a year the interest is added. Remember that it is compounded. So every single day, every single week or monthly, there is a compounding period. And when they advertise that interest rate, it does not take into account the fact that it will be compounded on whatever that rate is. Right? And this one is the one that is usually written per year. Hope that part makes sense there. Now, the effective interest rate. This is the actual interest you earn or pay in a year after taking compounding into account. Right, so this tells you the real value of the interest, especially when compounding happens more than once a year. I'm hoping that makes sense to everyone. Okay, now let's look at a simple example of nominal and effective interest rate. Okay, so a bank advertises a loan with 12% nominal interest rate per year, compounded monthly. Be very careful there. See, I put it in bold for you guys. It's compounded monthly. Right? What does this mean? This means that the bank adds interest each month, but the 12% is spread out over 12 months. Okay? So each month, they're actually charging you 1%. Right? Now, what we want to do is we actually want to calculate how much they are charging you due to the compounding period, because they said it's compounded monthly. So it's adding, it keeps on adding. So let's calculate that. Now, this is where I need you guys to pay attention. Remember that the formula is not given on the formula sheet. So this one, unfortunately, you have to remember. Okay. Now, to remember stuff, we'll come up with all sorts of mnemonics. So I always say there's only, now I'm going to take it to politics. I say there's only one EFF that I've heard of. Right? Now I know this is I effective. Okay? Then this is going to be equal to 1 plus I nominal over n to the power of n. If you have your own mnemonic that helps you remember this, that's perfect. Because I always used to confuse the positions of the nominal and the effective. Now let's just calculate. What is it that we're trying to calculate? We're trying to calculate the what? The effective rate. So what will we say? Take the one over to the other side. So the I effective is going to be 1 plus the I nominal over n to the power of n minus 1. Now let's substitute. I'm hoping they gave us everything. So this is 1 plus, what is the nominal interest? It's going to be 12%. Right? If you want to divide it by 12, I know, so if you want to divide it by 100, rather, if you want to take the 12 and divide it by 100, that's perfectly fine. I like using 12% because the calculator does have this symbol. So I don't have to complicate things. I can just put 12% over 12. But you don't have to change now. Whichever one you're comfortable with, that's perfect. Now, this will be to the power of 12. And then we subtract the 1. Okay? From here, it's just calculator work. Now, I'm going to let you guys plug this into the calculator. Make sure that you plug it in properly. Don't make any mistakes. And then please submit your answers in the chat. I'll give you guys 30 seconds to quickly plug this in, and then let's calculate the effective interest rate. Okay, thank you to the guys that are posting their answers. We are getting 12.68%. And that is what I got as well when I did the calculation. So even though the nominal rate is 12%, the effective rate is actually 12.68. And that's what you really pay instead of the advertised one. But this is because of the compounding period. I hope that makes sense to everyone. Please do not confuse the two now. Okay, now let's quickly move on. Remember to use the chat if there's anything that you would like me to repeat, but be very specific with what you would like me to repeat. Also, the guys that are watching live from TikTok, you are more than welcome to post your questions in the chat. Now moving on. Annuities, right? This is what they will test you primarily in metric, right? What is an annuity? An annuity is a series of regular equal payments or repayments plus interest earned on each payment. Okay, that's just a typo. It's meant to be on each payment. Once you start having multiple payments that are equal, now we're talking about annuities. Okay, we're all clear on what an annuity is, right? Now you have two kinds of annuities. You have the future value annuity, and you also have the present value annuity. Now, the future value, according to me, is the easiest one. Although the present one is equally easy, but the future value is more easy for people to understand. The calculations are exactly the same. Now, let's talk about it. A lot of people would say that the future is when you are saving, right? But let's not define it that way. Let's use the lump sum of money, right? Let's imagine a lump sum of money. If the lump sum of money is going to exist somewhere in the future, it doesn't exist now. That's when you use the future value. Okay, so let's look at the definition here. The future value is the value at some date in the future of a series of regular payments plus interest earned on those payments. Now you are saving money. Okay, so if you're saving money, the lump sum or the end amount, the big amount, is going to exist where? Somewhere in the future. That's when you use the future value annuity. Okay, now the formula says, let me just write it in bold for you guys. F is equal to x into open bracket 1 plus I to the power of n minus 1 all over I. Okay, this one you do not have to try and memorize. It will be given on the formula sheet. Okay, and this is what you use for future, when the lump sum of money is going to exist somewhere in the future. Now, X represents what? X represents that regular payment. Okay, regular payment. I is still the interest rate. And N represents the number of terms. And F is the future final amount. Okay, let me just explain my timeline, the one that you guys are seeing on your screen now. So I'm just representing my X's, my X as 1,000 rands. Okay, that is the regular payment. Now, I'm not going to consider, I'm just going to leave one of them out to just tell you about the months. These things are compounded monthly, right? Every single month we have a payment, and I'm considering it for 3 months. My X is 1,000 rands, and the interest rate in this account is 10% compounded monthly. And what we want is the final amount. How do we do that? We just plug in the formula. Our X is 1,000, open bracket twice, 1 plus the interest rate, which is 10%, but it's compounded monthly. Because it's compounded monthly, what do we have to do? What do we have to do to the 10%? If you know, please type in the chat. If you know what we have to do to this 10%, because it's compounded monthly, we have to divide it by 12. Absolutely. If it was compounded or compounded semi-annually, we would have to divide it by 2. Sometimes they will say half yearly. And there are 2 half years in a year. Okay, but this time we'll divide by 12 and then raise it to the power. I just want it to 3 years, or if you want, you can do the 4 years, right? Because there are 4 payments, but I had done it to 3 there, just so we're all on the same page. If you want to do 3, that's perfectly fine because I did 3 when I did the calculation. But if you want to do 4 because you're seeing 4 payments there, it's perfectly fine. I'll do 3 there and I'll say minus 1 and then over the interest rate, which is 10% over 12. Right. Now, when you are here on this step, I beg you guys to plug this into the calculator exactly like it is. Please do not change anything at all. Okay? Then you just plug this into the calculator. Now, here's a great question in the chat. So, sir, what is correct, 3 or 4 for in? Okay. Now, when I did the calculation, I used 3, right? But if you check here at T0, what do we understand by T0? T0 is when this thing happens, when you start this investment, right? Now you open the savings account, and the day that you open that savings account, what did you do? You decided to add a payment, right? So that is an additional payment. That's why you say plus 1. Okay. Now, without the plus 1, without this, I'm getting an answer in the chat. And that's 122,905, 06 or 07 if I'm converting to 2 decimal places. That is without, that is 3, and then 4, that'll give us a different answer because now we've added this very first payment. Okay, now there's a great question again in the chat. Let's just address it. Lewang is asking, are we not supposed to say 12? Oh, sorry, that's not Lewang. Okay, Lewang is saying, don't we divide the 10% by 100 first and then divide it by 12? You do not have to divide it by 100. So instead of saying 10 over 100, I leave it as 10% that is divided by 12. So 10% is the same as 10 over 100, and then you're dividing by 12. But if you're comfortable with saying 10%, with saying 10 divided by 100 first, and then dividing by 12, that's perfectly fine. It's just that I like it when it's clean like this. Otherwise, I get confused when I do the calculations. Okay. Now, Zizi is saying, isn't n 3 times 12? Great question. So what we're dealing with here is actually only 3 months, not 3 years. You must be very careful. I like that question. It's not 3 years. We're just doing it for 3 months, as stated there. Let's just underline it so that it's clear for everyone. That's the only reason it's not 3 times 12. If you're saying 3 times 12, it'll give you 36, which means now you're dealing with 36 months. All right. And that's the reason why we are not multiplying it with the n value as well, because we are dealing with those months as they are. We're not dealing with years. Okay. Somebody's asking me to repeat the definition of annuity. So, an annuity is a series of equal regular payments or repayments plus interest earned on each payment. If you'd like, you can take a screenshot of that. Just remember that it's supposed to be on here, off each payment, or on each payment. Okay. Now, there's a question on the plus 1. Let's look at what's happening, right? We have what we call T0. This is immediately when you open the account. let me say immediately there. So it's an immediate payment. Because usually, whenever you open something, or when you take out a loan, you always expect to pay when? To pay at the end of that particular month. But now, when you started this, you had 1,000 rands to save, and that is an immediate payment, right? So there are payments that you're going to make at the end of the month. Those are 3 payments. And this is an additional payment that you made in the beginning. That is why it is 3 plus 1. I'm hoping everyone is covered there. Okay, somebody's asking me to quickly go back to the interest rate. So an effective interest rate, this is the actual interest you earn or pay in a year after taking compounding into account. It tells the real value of the interest, especially when compounding happens more than once a year. Okay, that is effective. If you're taking a screenshot, that'll be quite quick. Okay, now the nominal interest rate is the interest rate that is stated or advertised. It does not consider how many times in a year the interest is added or compounded. Okay. There's another question. So how do we use the geometric series formula to get to the answer? Okay, so that one is a little bit advanced for you guys. You don't have to worry about it because we actually use the geometric series to come to the answer. Sorry, not the answer, but the formula, right? You guys don't have to prove this formula, especially if you are doing DBE. Even the IEB doesn't ask you guys to use to use the geometric series formula to do this, but I will do it. And I will record a great video on that. Just stay tuned to our TikTok and YouTube. You'll see me do that. For the sake of this session, I will not be doing that particular one. Both of you guys don't have to worry. So CAPS falls under DBE, and then IEB, you guys don't have to worry about where this comes from. You just have to plug it and then get to the answer. Okay. Now, if we're considering the immediate payment, then we have to say 3 plus 1. So which is going to give us 4 as our N. I'm hoping that is clear. If we're considering the immediate payment. Okay. All right, somebody saying they don't understand the future value concept. Let me explain it again. So let's say we start saving money, right? So we save money for a period of a year. So starting in January. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 months in a year, right? The beginning of the year, which is January, you decide to save 100 rands, right? Now, every single month after Jan, at the end of that month, you save 100 rands. So you are consistent with the amount, right? The regular payment. Okay. Once this year is complete, let's say this is the year 2025. You don't have the lump sum yet. You're still saving money. Currently, we are on month number 7, July. This is where we are. And you've managed to save every single month. The bank is giving you an interest rate of, let's say, 8% compounded monthly. You want to see, or you want to calculate how much you're going to have at the end of 2025. Remember, the year is not over yet, but you want to estimate how much you're going to have. As a mathematics student, you know you can use financial maths. Now, the money, the lump sum, is only going to exist when? At the end of 2025. You see, it doesn't exist now. The investment is still going on. It's ongoing. Okay? Because the investment is ongoing, the lump sum will only be done at the end in the future. That is why we use future value. Because the big money is only going to exist at a later stage. I'm hoping the concept of future value makes sense now. Hoping you guys can see the light. Okay. Now, explaining the immediate payment once again. I need you guys to pay extra attention. Right? They will tell you that an immediate payment was made. Okay? If they don't mention any immediate payment, so you must be very careful that you read the wording or the phrasing properly. Otherwise, that's where they catch you out in an exam. You might think that it's straightforward, but always use those 15 minutes that they give you before you start your exam to read the questions thoroughly. If they say an additional payment was made, that's when you need to add it there. If they don't mention anything about immediate payments, the formula is as it is. You don't have to worry about anything there. I'm hoping everyone is with me there. Okay, now quickly moving on to present value, because we still
Sorry
have to do
to
questions.
interrupt you, Tabang. We just
Yes.
have some two learners that have their hands up.
Okay, thank you
I
for
think
that.
we
I
should just give
didn't.
them an opportunity before you go. Um,
Perfect.
Namusi, I'm going to allow you to speak for you to ask your question.
Namusi, you've raised your hand. You can go ahead and ask your question. And Namusi, can you kindly repeat that? I don't think we got it. Otherwise, if you are struggling, I'm going to request you to just type your question if you are struggling with your microphone. Tafara, I think they might be struggling with their audio there. Maybe we can go to the other one who had their hand raised.
All right. Sorry, Namusi, please just type your question. Apology for that. We'll have the next learner allowed to talk.
Okay, Retsepile, you can go ahead. You can unmute yourself and ask your question. Retsepile, go ahead and unmute. Otherwise, we have to move on for the sake of time. Okay, maybe Retsepile is also struggling. Retsepile, just type in the chat if you are struggling to unmute yourself. Okay. Otherwise, I think we can move on. All right. So guys, please don't worry. For now, I'm still doing the explanations. I do have questions prepared and we will tackle all those questions together. Some of them I will give you guys to try by yourselves, but we will still look at future. We'll look at the present value. Okay. So Ritsepile, you've typed your question. The +1 was the immediate payment that was made because it was made at T0. And that's where we got it from. Okay, so let's quickly move on to present value annuities. Right, so for present value annuities, the comp or the lump sum of money is going to be different. Where does the lump sum of money exist? Okay, Asking me to zoom in. It's a little bit small. Let's try this. Okay, that should be a little bit better for you guys. All right. So with present value annuities, the lump sum is going to exist at a later, sorry, the lump sum exists now because you need the money now. So you want to start a business and you go to the bank to ask for a loan. It's because you want to start it immediately, right? Otherwise, if you want to start it maybe 5 years from now, what you want to do is you want to save that money instead of requesting that loan. Okay, present value, the money exists now. You just write it there. It exists in the present or now. Okay, are we together there? The money exists presently. Now, the X is still the same. The X is the regular repayment. The I is the interest rate, and N would be the number of terms. Okay. Now let's check what they say there. A sum of money is normally borrowed from a financial institution and paid back with interest by means of regular payment or regular payments at equal intervals over a time period. Okay. Now, let's check what's happening here. This is you going to the bank at T0. You're going to ask them to borrow you money because you want to start a business, maybe selling fruits or whatever. Now, you go here because you don't have the money. You cannot make an immediate payment, right? Otherwise, if you have an immediate payment, we consider it to be a deposit. But we'll deal with those when we do the questions. Okay, this is where you go to the bank. Now, at the end of the month, that's when you start making payments. So if I went to the bank now, I want money to start a business, maybe they'll grant my loan tomorrow or before the end of this particular week. Then they'll say, that's fine. You can take the money. Then your first payment, we need it at the end of July. Second payment, end of August. Third payment, end of September. I hope we're all clear there. Like I said, the X is the same. All right, I think everyone is clear. I'm seeing a thanks in the chat. Okay, I think you guys are with me. Remember, guys, if you do not understand or if you're losing me, if I'm losing you, please do type in the chat, right? And if you have questions, please be very specific with your questions. To the guys who are watching on TikTok as well, you are more than welcome to ask your questions in the chat, and we'll try our level best to make sure that your questions are answered. Remember, you need to be very specific. When you say, sir, please repeat, I have no idea which part you'd like me to repeat. So please say, sir, repeat question so and so, or sir, I didn't get this part. I will repeat that. But please repeat, I don't know what you'd like me to repeat. Okay. Please repeat present annuity and what lump sum is. Okay. So a lump sum is I'm going to put it in quotation marks, a large amount of money or a larger amount of money, right? I'm saying larger because this will always be greater than the regular payment, right? So for example, the loan that was granted to me was 10,000 rands. That is a lump sum. That is the money that they gave me at once. Larger amount of money given once off. What I'm going to do is I'm going to be paying the bank 1,000 rands every single month. The 1,000 rands that I'm paying every single month, those are X, right? Those are the regular payments. But what the bank gave me is what? Is the lump sum. It was a once-off payment to me. Okay. I hope it's clear there. Now, let's then apply this. The formula P is equal to X into 1 minus 1 plus I to the power of negative N. Be very careful there. Please do not try to memorize these formulas. Okay? Just take it from the formula sheet as it is. Now, what we want to do is we want to try and calculate. So let's say the payments are 3 payments, right? These are not years, months. I'm going to write month, month. I want everyone to be with me there. These are not years, but these are months. So please do not say 3 times 12. We want to calculate P. We're going to assume our X to be 1,000. The interest rate is given to be 10% compounded monthly. Okay. And what we want is our P. Okay. We're going to plug that in, but before we plug it in, let's answer the question in the chat. Why do we say negative N? That's a great question. We say negative N because you cannot keep paying forever. Imagine, single, if you took a loan, right, maybe for 10,000 rands, they granted you the loan and you guys agreed that you're going to pay them 500 rands every single month. But then you never stop paying them. That's very much unfair, right? So the negative N ensures that at the end of the day, we have paid them their money. Otherwise, no one is going to take those loans. Yes, so it is deduction of the loans. Because when you pay, the loan amount keeps getting smaller and smaller. Okay. So the definition is given here. You can just take a screenshot. I don't think there's any other definition. Yeah. Here we go. Take a screenshot real quick, and then we can move on so that we can also look at some of the questions. Perfect. Let's then find the principal amount here. So the X is 1,000. 1 minus 1 plus the interest, which is how much? 10% over 12 because it's compounded monthly, right? Now, I want somebody to do it this way. I want somebody to say 10 divided by 100, and then this answer, you're going to divide it by 12. We must get the same answer at the end. Just so I can show you guys that both of these will work. I just prefer the earlier method. So we'll say minus what? Who can guess? What number do I have to put here for in? If you've got it, please type it in the chat. 3, that's perfect. Remember, we're not dealing with years. Yes, you guys are correct. Yes, I had already attached the negative, but if you said negative 3, that's perfectly fine. I know where you're coming from. Thank you so much, guys. You guys are with me. 10% over 12. Now, what you want to do is you want to plug this into the calculator exactly like it is. Please do not change anything. Plug it into the calculator exactly like it is. Once you have an answer for me, please do type it in the chat so I can write it here. And remember, guys, please share the link with your classmates or any people or any person that you know might benefit from the sessions. Okay, so we are doing this question here. Somebody's asking, is it not 15%? We are not doing this one. Let me just cancel it out. We are not doing this particular problem. what we are doing is this one here with 10%. Please make sure you're using the 10%, not the 15%. Okay, looks like we're all getting the same answer, which is 2,950,59. What does this mean? This means this is the amount that the bank borrowed you. I think we're all together there, right? Must we always round off to two decimal places? Yes. Usually in your exam guidelines, in the exam instructions, they will specify, but it's been two decimal places for quite a long time. So I made a mistake. It's supposed to be 69, not 59. It's just a silly mistake. I apologize for that. Thank you for correcting me. Just a silly mistake on my side. Okay, somebody's saying if there's a comma, isn't it an indication of a payment that wasn't full? Okay, so not in this case in Kobo, only because what we were trying to calculate was the present amount, the amount that the bank gave you. So you went to the bank and then the bank gave you this as a loan. We were not trying to calculate X, but we were trying to calculate how much they actually gave you from the bank. Hope everyone is with me there. Okay, now let's look at this particular question. Okay, let's zoom in. Not question, but balance outstanding. Okay. Now, this can be a little bit tricky for a lot of people. Okay, so here's a question. What if they said 3 payments instead of 3 months? So if they say 3 payments, they need to be a little bit specific, right? They need to be more specific than that because 3 payments is not really telling us anything. 3 payments over how long? Was it 1 payment every year for 3 years? Was it 1 payment every year over 6 years? Or 1 payment every 2 years over 6 years? So they need to give you more information. I hope that makes sense, Emma. So balance outstanding. This can be a little bit confusing. So what I always do is I take the present value of the outstanding term. What do I even mean by that? Okay, so let's look at this. It is often the case that in annuity investments, payment are made at T0. This means that the last payment in the annuity is made 1 month before the investment pays out. An example is that, okay. So what we want to do is we're going to consider this timeline, all right? Now, if we're considering this timeline here, when I'm saying the outstanding balance of the outstanding term, it's how much you actually owe the bank, okay? So let's go back to our months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we started in January. We have to end in December. That was the agreement with the bank. Now, you have made 1,000 Rand payments until June. Let's say this is June. Every single month, you were able to make 1,000 Rands worth of payment. But now your business was doing so well that you were able to save money while you were paying the bank back. You want to see, so you see this month of July, you want to see how much you actually owe the bank. How do we calculate that? That's when we use the present value of the outstanding term. How many terms, how many months do you actually owe them? You owe them for July, August, September, October, November, and December. So it means that there are 6 months outstanding. Please make sure that you're with me. 6 months, outstanding. If you're with me, please do a thumbs up. Okay, I'm seeing a thumbs up. I think you guys are with me. If you're not with me, maybe just press the heart so I can re-explain it. Okay, cool. I'm going to re-explain. So we've asked the bank for some money, right? The bank borrowed us that money. And this was in the beginning of this year that we're in. This is 2025, right? They gave us the money at the beginning of January. The end of January, we were able to make a payment. So let me use green to show. So January, payment made. February, March, April, May, June. We've made those payments. What month is the current month? This is July, and this is the 8th. Our business has been doing so well that we have some money. Right now, we have some money, and we want to use this money wisely. We want to pay back the bank the money that we owe them. Is everyone with me there? A thumbs up if you're with me. Perfect. We're all together. Right? Now, because we want to pay back the bank, we need to check. We need to pay back for which month? For July, for August, September, October, November, and December. That was the original agreement. That was what we agreed on, that we will pay them for these months that are still to come. Because if we didn't have a lump sum of money now to pay them back, we're going to pay for July. End of August, we're going to pay. End of September, we're going to pay until the year ends. But now we want to finish that date today. And we want to check how much you actually owe them. Right. The interest rate is 10%. Right? And N is simply going to be 6 but months. Because those are the outstanding months. The interest rate, I did say that it's 10%. Let's calculate. The formula is P is equal to X into 1 minus 1 plus the interest rate, negative N over I. What is it that we're trying to calculate? We're trying to calculate that, the balance outstanding. Our X, 1,000. 1 minus 1 plus the interest rate, which is 10% compounded monthly. Now, what do I have to put here? Can anyone guess? If you've got it, please do type in the chat. What is my power? 6. 6 is the correct answer. Yes, it is a negative because those are the months that we still owe the bank. And then this is over 10% over 12. Now all we do is we plug that into the calculator and we get an answer. Okay, why is it 6? Because like I've been saying that we've made a payment since January, every single month since the beginning of January this year. We're able to make a payment of 1,000 rands. We still owe them for what? For 6 more months of the year. But since the answer seems rather small, please double check. Yes. 5,828 is the correct answer. The 6 months are the outstanding months. That is the outstanding term. I'm hoping it makes sense there. So the P, the outstanding that you owe the bank is actually 5,828,82. This is how much you can pay them to settle the loan. If you pay them this amount of money, then you're done. Otherwise, if you don't pay them and you stick to the 1,000 rands, you're going to end up paying them 6,000 rands. But now you've saved 160 something or 171 rands. Okay, for the sake of time, we're going to move on so that we can also look at the questions. Okay, now let's just quickly try to address sinking funds, right? Maybe it'll make more sense when we do the actual questions. Okay, so businesses often set up savings plan at a time of purchasing equipment to save up for its replacement. So a sinking fund is just a future value annuity. Okay, so because we are saving money, the lump sum is going to exist at a later stage, right? Now, let's say this. Our business is maybe we own a bus that transports school children to school, right? We bought the bus, but remember that the more it's used, the more it depreciates. That asset will depreciate because it gets used. Um, there will be normal wear and tear on the bus. After some time, it will be very old. Right? If we bought the bus for like 2 million rands at the beginning of this year, if we decide to sell it now, it's not worth 2 million rands. I'm not talking about the business, I'm just talking about the bus itself. Because it's been getting used every single day or however frequent, what's going to happen? The value of that bus is going to depreciate. But now, we are very good business people. We know that we would have to replace this bus after 7 years. And then we decide to save money. So after 7 years, this bus, so we bought it for 2 million rand. After 7 years, when we sell it, it's maybe going to be worth, it depends how much it was worn out. Maybe let's say it was worth 400,000. And the new bus, 4 years from now, costs 2.3 million. It means we need 1.9 million to actually buy this bus. Let me just write down what I'm saying. So 2025, the bus cost 2 million. Now, 4 years later, so 2025, so because we bought it at the beginning of 2025. So 2026 is a full year, 7, 8, and 9. So end of 2028, that'll be a full year. So now the very same bus that we bought for 2 million has depreciated in value. It now costs how much? It now costs 400,000 rands. Okay? But now, if we wanted to buy a new bus this year, 2028, because of inflation, the new bus cost how much? Let's just say 2 million, let's just say 100,000. That's the cost of a new bus. Okay, we're going to sell our old bus at the end of 2028 for how much? For 400,000. So we sell it at the end, we have 400,000, but the new bus costs 2,100,000. How much do we need? We need 2 million minus 400,000. That's how much we need. And that's going to be how much? 1,700,000. Because we don't have this kind of cash lying around, we decided to open a savings account so that as our passengers are getting on the bus, some of the profit goes towards replacing this bus. Remember, it's 2,100,000. It's not just 2 million. So the new bus at the end of 2028 costs 2,100,000. I think you used the amount that we used in 2025. So we decided to save the 1,700,000 rands every single month, bit by bit. And this is a sinking fund. Okay, we know that at the end of 4 years, we need, so end of 4 years, we need how much? We need 1.7 million. The bank gave us an interest rate of 8% compounded monthly. What we want is to calculate X. Okay, everyone is happy now. What we want is to calculate X. Okay, let's just move this out of the way so I can do that calculation properly. What are we going to do? I said we are saving, so the lump sum of money, this money that we need is going to exist somewhere in the future. So this means that we have to use which annuity? The future value. So F is equal to X into 1 plus I positive N minus 1 close bracket all over I. Please do not try to memorize the formulas. Make sure that you're using the formulas as per the formula sheet to avoid silly mistakes that can occur. Our F is going to be how much? 1,700,000. X is how much? That's what we want to find. One plus the interest rate, which is how much? We say the interest rate, let's say it's 8% compounded monthly. How many years? 4 years. It's 4 years and every single month. That's why now we are saying times 12 minus 1 over 8% over 12. Everyone with me? Now check what I'm going to do. 1,700,000 multiplied by 8% over 12 is equal to 1 plus 8% over 12 to the power of 48 minus 1. Okay, please guys assist me with this answer on the calculator as I just made this question up. Make sure it's 1, 7 and 5 zeros. I just want this answer on the left for now so we can do it step by step. Okay, then we know that our answer, we just need to divide both sides. So I got 1,1,333, 3, 3. I'm pretty sure that is the final answer. Okay, so let's do it step by step. We're going to have to divide by whatever this bracket is so that we can solve for X. Because remember that these two cancel each other out. So people got an answer of this. We're just going to double check if we're all getting the same answer. So for this guy here, we're getting let's just say multiply. Okay, we're getting 1,1,333. Okay, I thought that was the final answer. And I'm with you guys now. And all we need to do is we need to divide this answer by how much? By that bracket. Which bracket? 1 plus 8% over 12 to the power of 48 minus 1. And that gives us 30,168. Okay, let's quickly re-explain it again. So I'm going to go over it briefly. I said at the beginning of 2025, we bought a bus for 2 million rands. We know at the end of 2028, we need to replace this because it's now broken or it doesn't function properly. We need to replace it. But it's worth something when we are going to sell it in 2028. We decide to sell it in 2028 for how much? For 400,000. That's how much they gave us. Now we have 400,000 after selling that bus that has been with us for 4 years. Okay? We have 400,000, but we need to go and buy a new bus now. Guess how much a new bus costs now? It costs 2,100,000. But we already have 400,000. That is why we said 2,100,000 minus the 400,000. It means what we actually need is how much? Is 1,700,000 because we had the 400,000. Now, we know that we're going to save that money, that 1,700,000. And how much do we need to put in the account every single month for us to reach 1,700,000? And that's what we've been calculating. We want to know what X is. For us to reach 1,700,000, how much do we need to save every single month? And we found that amount to be 30,168.63. That's what we've been trying to do. Okay. Here's a question. So please explain why it's 4 times 12 instead of 4 times 4. What did they say? It's compounded what? Monthly. Here, I wrote it. Compounded monthly. So every single month. It's not just once a year. If it was compounded yearly, we're going to say 4 years because it's once every single year. But this one is compounded monthly. So year number 1, you have 12 months. Year number 2, another 12 months. 3, 12. 4, another 12. So what is the total here? The total is 48 months if we consider the compounding. Okay. I hope that is clear. Okay. I'm going to quickly move on so that we can address some of the questions here. Provided we have time, I'm going to come back to some of those slides there, but I gave you guys the core concept that you need to tackle this topic properly. Okay, so let's look at this one together. A bank quotes an interest rate of 13.2% per annum compounded monthly. Calculate the effective annual interest rate. Right. So what do we know about this one? This is the nominal. Are we together there? So I'm going to let you guys attempt it because I've given you the tools that you need to address this topic. So I want you guys to try and calculate the nominal interest rate in that regard. Sorry, they give you the nominal. I want you to calculate I effective. My wording is wrong. We want to calculate the effective interest rate. If you've got an answer for me, please do post it in the chat. There we go. Now we can all see. So if you've just joined us, remember we did discuss the difference between nominal and effective. And we've spent quite a lot of time doing the explanation. The nominal one is the one that is usually advertised without the compounding periods. Okay, I have written the formula before. I want you guys to take notes as I am explaining here, because I am explaining quite slowly and I do give you time to take down notes. I do end up repeating as well. Remember that this formula is not given on the formula sheet. This one you have to remember. And I said I come up with a mnemonic where I say there's only one if, and then this is 1 plus I nominal over n to the power of a. And then we're looking for I effective. So I effective is equal to 1 plus the nominal, which is 13.2% over 12, because it's compounded monthly. For how long? For a year. And then we're going to say minus 1 because we took it from the left-hand side. Calculator work from there. Plug this into the calculator exactly like it is. Okay. Should be getting 0.14028 and some numbers. As a percentage, this is going to be 14.03. This is correct to 2 decimal places, and it's a percent. Hope everyone is covered there. If you're taking down notes, quickly take a screenshot. And remember, guys, if you have questions, please use the Q&A or alternatively use the chat. If you have a question, you can raise your hand and we'll try to unmute you so that you can ask your questions. To the guys that are watching on TikTok, you guys can post your questions in the chat. And also remember to share the link with your classmates or friends or people you know will definitely benefit from the session. Remember to like and subscribe and follow our social media platforms. Okay, now let's look at this one together as well. Let's try to move quickly so we can get to the annuities as well. Calculate the rate of depreciation required for a car to halve its value from 200,000 to 100,000 over 6 years on a reducing balance. Okay, so the first thing that I'm seeing is reducing balance. That's very important. Reducing balance, I did tell you guys which formula we're going to use. It is the compounding, but it's reducing. So A is equal to P1 plus by the negative I to the power of A. That's the reducing balance. Okay. Now, between the 200 and the 100,000. So which one is the 200? Let me ask this question. Is the 200 A or is it P? That's the question I'm posing to you guys. The 200,000, is it going to be our A or is it going to be our P? The 200 is definitely going to be our A. It's not the principal. Oh, sorry, my mistake. Sorry, I'm reading this wrong. I'm going to correct myself. They say it's going to halve its value. So it started, where did it start? It started at 200. So starts there as 200,000 and then it depreciates. I'm correcting myself. So sorry for the silly mistake. It depreciates to 100,000. Okay, let's just understand that. Starts at 200,000. Ends at 100,000. Hope we're all together there. I made a silly mistake. I apologize for that. Now, let's substitute. What did we say? We said that A is the end amount. So we can say this is 100,000. Now, Our P is going to be that 200,000 that we just spoke about. 1 minus I to the power of what? To the power of 6. Okay? Litle saying that they're lost. Litle, please do say where you are lost so we can help you out. If you're saying you're lost, we don't know where to come and get you. Give us some coordinates, some direction. Okay, so let's look at this. Remember I explained that A is the what? The end amount. P is what it costs now presently. So let me ask you, okay, how much does the car cost now? Okay, I hope you're with me. No, that's not how much the car costs. Read the question properly. It's saying calculate the rate of depreciation for a car to halve its value from where? From 200,000. That's what the car costs. It costs 200,000. And then as you use it, it's going to depreciate in value. So you bought it for 200,000. After some time, it's going to now decrease to 100,000. So the end amount is the 100,000. That is the end. The beginning amount when we bought it for 200,000. I'm hoping that makes sense. Okay, moving on. Now what do we need to do? We simply need to divide so that we can solve for I. I'm going to divide both sides by 200,000. I'm going to have 1 over 2. This is equal to 1 minus I to the power of 6. How do we get rid of that? We'll take the 6th root. You can say plus or minus, but I know the negative is not going to matter because this is an interest rate which has to be positive. Okay, these two cancel each other out, and then we know this is the 6th root of a half. So 1 minus that is equal to the interest rate. So I took the I to that side, it became positive, and the 6th root of a half to the other side, it became negative, and I just rearranged. Plug this into the calculator, and the interest rate is simply going to give you 10.91%. And that is the interest rate. I'm hoping you guys are with me. Okay, great stuff. We're all together there. Now let's move on to this other one. Let's be very careful with the A and the P. So a TV costs 6,000 rands in January 2020. Now the average rate of inflation has been 5.5% per annum over the past 5 years. Okay, calculate how much a similar TV would have cost in January 2015. Is everyone with me there? Now we are dating it backwards. What is it that we're trying to calculate? We're trying to calculate how much it costed back then. So TV cost 6,000 in January 2020. The average rate of inflation has been 5.5% per annum over the past 5 years. Calculate how much a similar TV would have cost in January 2020 or 2015 rather. How many years? 5 years. The interest rate 5.5%. Now, what is it that you're looking for? You're looking for P. There we go. We're looking for P. I'm going to let you guys quickly calculate it. As soon as you have an answer, please do share it in the chat. Then we are going to check who got the right answer. And if you didn't get the correct answer, that's perfectly fine. That's how we learn. We learn from our mistakes. Please do attempt the questions that I give you guys so that you can see where you're going wrong. Okay. Okay, I'm getting two different answers. Thank you so much, guys, for the answers that are coming. Okay, the answers are now different. Thank you guys for attempting. I'll give you 20 more seconds if you're attempting, and then we will mark. Make sure that you do attempt. Okay, we're getting different answers. Thank you so much for that. Let's see who got it right. Okay. I'm seeing a lot of 4590,81. There's another 7961,45. And then there's also I'm not going to write all the answers, but I'll just write the few. There's a 3826,66. Let's check if any of these are correct. Okay, so which formula are we going to use? A is equal to P into 1 plus I to the power of N. Okay, for inflation, you use that. And let's check. We're looking for P. What is our A going to be? It's going to be 6,000 because we're working our way backwards. The principal, that's what we're trying to find, 1 plus the interest rate, which is how much? 5.5% over how many years is this? I'll just say over 1, sorry, because it was not monthly. Just need to divide by 100 only. Otherwise, I can just say, because I'd already written it in fraction form, I can just say it's 5.5%. For how long? 5 years. Then we know that our P is simply going to be 6,000, 1 plus 5.5% to the power of 5. And that should give you how much? 4,590,81. If you didn't get it right, do not despair. If you got it right, celebrations in the chat or a thumbs up in the chat. Congratulations to you. If you didn't get it, just a heart, and I will quickly just go over it again. All right, cool. So there are people who would like me to go over it again quickly. So with finance, the trick is understanding the English, right? We need to be very careful with the English. So the TV cost 6,000 in January 2020. So we are going to assume that this is the year that we are in. Let's just say that this is now. 5 years ago, the very same TV costed something less. So now at the end, and remember that the end is A. Now it costs 6,000. Previously, it costed something. That's what we're trying to calculate. The interest rate is given 5.5. It's not compounded. You just say 5.5%, or you just say 5.5 divided by 100. And they said how many? They said 5 years. And that's why our power there is 5. And from there, it's just calculator work. Yes, we use compound formula for inflation. Okay. Now, I'm going to let you guys attempt some of these problems, but we will still mark together. Okay? Let's check these ones out. Please make sure that you do attempt them so that you can see if you're actually on the same page with us or if you need some help. Okay? Now, the very first question, I'm going to read it for you and maybe I will give you guys hints as well and tips to attempt this. Wendy has some money to invest. She goes to two banks to find out what they offer. Peninsula Savings offers 8% per annum compounded monthly, and Corporate Capital offers 9% per annum compounded annually. Calculate the effective annual interest rate for Peninsula Savings. That's the first part. Now, part B, hence compare the two banks and help Wendy decide which bank offers the better investment, right? It might look like Capital offers more because it says 9%, but it's compounded annually. And then Peninsula offers 8% compounded monthly. We don't know yet. It could be Capital, it could be Peninsula. What do we need? We need the effective interest. I hope you guys are with me. So calculate the effective interest for Peninsula. Because this, they said it's compounded annually. So this is already effective because it is annually. Okay, let's do that. There we go. So for Peninsula, you want to calculate the effective. If you have an answer, please do type it in the chat. Okay, I'm seeing 8.3%, a lot in the chat. If you have a different answer, please do type it. I'm just acknowledging the 8.3%. I'm not saying it's wrong or right. Okay. Now, I gave you guys the formula. You now know there's only one EFF and then 1 plus I nominal over n all to the power of n. Okay, then if you plug that formula, our effective interest, so 1 plus I effective is equal to 1 plus 8% over 12 to the power of 12. Let me just say effective is that. Then from there, it's just going to be calculator work for you to calculate the effective interest rate. And I hope that makes sense to you guys. I effective gives you how much? 8.3%. Now we have the effective here as well. So which one makes sense? It makes sense to go with corporate capital. Corporate capital with the 9%, that's the one that she should go with because they already have an effective interest rate of 9%, whereas Peninsula's effective interest is only how much? 8.3. You can only compare effective interest rates. Single, please make sure that you are typing or plugging it into the calculator exactly like it is. Okay. Donolo, I think you confused the two. Okay. You guys are doing very, very well. Thank you so much for attempting. Let's go to the other one. I'll give you a hint as well. So my car costs 245,000 when it was new. That's how much it costed. Okay. Now it's worth 110,000. Calculate the annual rate of depreciation on a reducing balance if the car is now 5 years old. Give your answer correct to one decimal place. It doesn't matter that much. I don't really mind this, even if you put two, because usually with you guys, they will say two decimal places. Okay, I'll go back to repeat once we're done. I know people have already attempted or have already started with this question. What is it that we're trying to calculate there? We're trying to calculate the interest rate. Now, here's a question. Is this going to be P or is it going to be A? Is the 245,000 P or is it A? It is definitely P. That's the principle. At the end, it was 110,000. Now calculate the interest rate. Okay, if you have an answer, please do type it in the chat. Okay, Dewayne got 14,8. Thank you, Dewayne. We're going to check just now, right? So we know the formula is going to be A is equal to P into 1 minus I to the power of N, because they said what? Reducing balance. And 110,000 rands is equal to 245,000, 1 minus the interest rate, which is how much? Which is what we're trying to find, to the power of 5. 110 over 245,000 is equal to 1 minus I to the power of 5. Then we can say the fifth root of that so that we get rid of this. Now we can say I is equal to 1 minus the fifth root of 110,000,245,000, just like that. And then you are going to get 14,8%. And that is how you deal with such a question. Right? Now, let's quickly move on. For the sake of time, we have to look at some annuities as well. Okay, let's look at this one. Susan buys a car for 350,000. She secures a loan at an interest rate of 7% per annum compounded monthly. That's a great interest rate. Compounded monthly. The monthly installment is 6,300. She pays the first installment 1 month after the loan was secured. That's perfect. Usually when loans are granted, you only pay the next month. All right? Now, calculate the effective annual interest rate on the loan. Leave your answer correct to two decimal places. Okay, you guys are going to attempt that one quickly. I know you know how to deal with it. Once you have an answer for me, you are more than welcome to share it. Okay, once you have an answer, please do share it in the chat. The answers coming in the chat. Thank you for those answers. We will mark shortly. Right, for the sake of time, let's quickly check. What is it that we're trying to calculate? It's given the effective annual interest rate. So I effective is equal to what? 1 plus what percent? This percent, 7%. So 7% over 12 to the power of 12 minus 1. And that gives you your interest rate. That's how people were able to get it so quickly. And I effective will be 0, 0.07229. Now, it means that the effective interest rate is going to simply be 7.23%. Great stuff. Now you guys know where it comes from. Let's quickly attempt 9.2 together. Okay. Firstly, we need to identify what's happening here. The lump sum of money, does it exist now or is it going to exist somewhere in the future? That's the question that you need to ask yourself before you use the present or the future value. This 350, does it exist now or is it going to exist somewhere in the future? It exists now. Definitely, it exists now. Because it exists now, we're going to use what? The present value. So P is equal to X into, let me just fix that. Just a second. Sorry about that. 1 minus 1 plus I to the negative n over I. Don't be like me. Please rely on the formula sheet for the formulas. In case I made a mistake, but I think we're all good. If I made a mistake, you're more than welcome to correct me. Now, what is it that we're trying to calculate? How long this is in, how many months? Okay, our P is going to be 350,000. What's X? It is said that it's 6,300. 1 minus 1 plus, what is the interest? The interest is going to be 0.07. Compounded monthly to the negative. How long? I will say 12 in. Close our bracket B. This is going to be 0.07 over 12. Hope everyone is with me there. Now, this is some basic mathematics, and I know you guys are quite good with algebra. So 350,000 multiplied by 7% over 12. But this is all over. Make sure that it's all over 6,300 is equal to how much? 1 minus 1 plus 7% over 12 to the negative 12 in. Okay, that's a great question. Zakari is saying, why do we use in if it's number of months and not years? So I'm guessing you're saying, why did I put the 12? The question did say how many months, so I don't have to put the 12 there. I assumed that they were asking for years. That's why I immediately put the 12. But we don't have to put that 12 there because they are looking for months. The answer that we're going to get will be in months. Otherwise, then we would have to multiply by 12 again. So I just need to get rid of this. And if you used it that way, I apologize. You can just use negative in because the question is asking for months, not years. Okay. Then from here, it's going to be some easy mathematics. So I'm going to say 73 over 108 is equal to the bracket 1 plus 7% over 12 to the power of negative n. So all I did is I took this part way to the side and I brought this cloud to the right hand side. Calculator work. If they ask you for years, you are going to include the 12. The 12 that I just omitted, that's what you're going to include. Then what do we do when it's like this? You log both sides. So log of 73, 73 over 108 is equal to negative n log of 1 plus 7% over 12. Then what do we do? Solve for n. It's going to be quite easy for you guys. Just rely on your calculator. Make sure that your algebra does not have any mistakes. It is a lot of algebra, but it's easy stuff for us. So these two cancel each other out, this and that, and then we just find what this is. So n is going to give you, if you divide away the negative, 67,3393, just like that. Which means that n is actually 67, because of the 9, that will have to change to a 4. And that's in months. I hope that makes sense to you guys. Okay, if you're taking it down, please do so quickly. I'll zoom out so that you can take a screenshot and then we can move on. Right. So the reason we don't say it's 68, it's because the last payment is not going to be a full payment. So you might find that you only have to pay 2,000 rands from the 6,300 rand. It's not 68 full months, but it's 67,34 months. So the 3,4, so 0,34 months are not a full month. So you are not expected to pay the full amount. Okay, so for log, all we did is we introduced the log on both sides. So you literally just say log there. This is what we introduced there. And we introduced the log on the right. But the rule says if you have a power and a log, the power can come in front here. It's as if we are deriving. That's how you need to think of it. And then we divide it so that we can find n by itself. How did I get 73 over 108? All I did is I took this blue part to the left hand side and I took the blue cloud to the right hand side. So 1, this one here, minus the blue cloud, it will give you 73 over 108, and then you log both sides. Okay, so definitely it is 67 full payments. And then the 8th one, the 68th one is not a full payment. So you don't have to pay the full 6,300 rands. There will be a discount there. Okay, so the reason I removed the 12 is because the question was asking us for months. It wasn't asking for years. It was asking for months. If it was asking for years, I'd have to put the 12th day and then divide by 12. Because this divided by 12 will give you the number of years, 5 comma something years. So if it was for years, we're simply going to include the 12th day. If you don't want to include the 12, you just divide by 12 at the end. Okay, we're all good there. Now, let's quickly move on to the next one, just for the sake of time. 9.3, calculate the final installment. See, that's where it comes in now. How much is going to be the final installment? It's for 5 marks, right? It shouldn't be that bad at all. I'm going to help you guys with the final installment. So we need to understand something. The final installment is after what? It's after 67 full payments. Are we together? So what I'm going to do is I'm going to take the present value of the outstanding term. That's the easiest way to go about it. Present value. So we're looking for the balance outstanding, BO. So take the present value of the outstanding term. So P is equal to X into 1 minus 1 plus I to the negative N, close bracket, all over I. Check what I'm going to do. How much are the regular payments? The regular payments are 6,300. 1 minus 1 plus, what is the interest rate? 7% over 12. Right. Now, negative. Who can guess what we have to put in the place of in? Let's check. What do we have to put in for the place of in n's place? Nonglebo, you got it right. It has to be the 0.34 because that is the outstanding term. Remember, in my explanation, I said that is the what? The outstanding terms. You've made the 67 payments. You've made them. How many payments are left? It's the 0.3393. So I'm going to say 0.3393. I wanted it to be more accurate. That is what is outstanding. The other payments we have made. Remember what I said in my explanation. The outstanding term. Now this is 7% over 12. Then all you do, you plug this into the calculator and check what it gives you. It must give you how much? 2,142.21. And just like that, you got your 5 marks. Here is the question. Calculate the value of the final installment. Unless you're looking for the very first question. Okay, let's do this. Then it's going to be a little bit blurred. So we're looking for the final installment, and the statement was this. Great question from Zakari. How do we know we didn't pay the 0.34? Because that's what they are asking us. The question is saying the final installment. That 0.34 is what they are asking us. We haven't paid it yet. They want to know what it is going to be. So the payments that we're making are 67 3393. But how many full payments have we made? We've made 67 full payments. Now, if you subtract, we know that this is going to fall away. We're going to be left with what? 0, 3393, because we've made 67 full payments. Yes, Zakari, we have paid for 67 months so far. And this is what is left. This is the outstanding term. So I didn't use 0.34 because I wanted it to be more accurate. So that is why I used 4 decimal places. I only round off my final answer to 2 decimal places. Anything else, I usually use 5 or 6 decimal places so that I have a very accurate answer. At 3.4, it's because we converted or rounded off to 2 decimal places. 0.339 is the same as 0.34 if you round off to 2 decimal places. Yes, for accuracy's sake, always use what you get from the calculator. Right? If you don't want to use the whole thing because it can be quite long and you don't have a lot of time in the exam, what you need to do is use 5 or 6 decimal points. I used 4 and it still worked. Okay. If you are taking it down, please do so quickly. But this is how you go about calculating that balance outstanding. That's why I just said BOD. It's very easy to do balance outstanding by looking at the outstanding term. Instead of finding the compound minus the future value, you can get lost somewhere there. And I always say to my learners, always take the easy way out as long as you're getting all the marks. Right? Show all the steps. Remember, the final exam usually has 3 or more solutions to every problem. Not all of them. Some of them, maybe there's only one solution. But as long as it's part of the memo, you will get it right. All right, guys, the time is now 19:59. You guys have been a great audience. Thank you so much for joining us for today's session. We will definitely end here for today. Remember, tomorrow we will be having more sessions. Tomorrow, Wednesday, we will be looking at mathematics, which will be covering functions. And I will take you guys through functions. Please make sure that you share the link with your classmates and your friends. Remember to like, subscribe, or follow our various social media platforms, just so we can help, just so you can help us bring you this awesome content at no charge at all. And we're going to end here for today.